The most common type of divergent plate boundaries are ocean-to-ocean divergent boundaries. These boundaries usually occur along mid-ocean ridges. This is where new oceanic lithosphere is created. As this is where sea floor spreading begins, these areas are called spreading centers. These boundaries form when two plates begin to move away from each other. Divergent boundaries appear along mid-ocean ridges in the ocean and across rift valleys in northwestern Europe and East Africa. The picture you are looking at is the Great Rift Valley in Africa. When a continental-to-continental divergent plate boundary forms on land, it can literally tear a continent apart. When the lithosphere begins to stretch, the two plates begin to separate. Hot rock then rises from beneath the Earth's surface. This causes the crust to weaken. When magma reaches the Earth's surface, a rift valley is born. Some examples of rift valleys are the Rhine Valley in northwestern Europe and the Great Rift Valley in East Africa. The picture you are viewing is a diagram of a continental to oceanic plate convergent boundary. When the continental lithosphere converges with the oceanic lithosphere, the continental lithosphere remains floating. The oceanic lithosphere sinks to the asthenosphere. When the oceanic lithosphere begins to reach a depth of 100 to 150 kilometers, the asthenosphere begins to melt. When the asthenosphere begins to melt, magma forms. The newly formed magma, which is less dense than the mantle, rises to the surface. Eventually, the magma can reach volcanoes where it will erupt. These types of plate boundaries are commonly found in the Andes in South America and at the boundaries of the Nazca Plate. The picture you are currently looking at is an example of a continental-to-continental convergent plate boundary. In a continental-to-continental plate boundary, the oceanic lithosphere is still involved. The oceanic lithosphere is subducted beneath the continental lithosphere. The second continental plate will then bring the two continents together through the process of subduction. The continental lithosphere is not subducted because it is less dense than the oceanic lithosphere. This collision can cause the creation of mountains. This process has happened during the creation of the Himalayas and the Swiss Alps, the Appalachians, and the Urals. The picture you are currently looking at is a diagram of a hotspot. In a transform fault boundary, pieces of the lithosphere grind past each other in a horizontal fashion. They grind past each other in a way that does not destroy the lithosphere. Most transform fault boundaries usually join mid-ocean ridges. Transform fault boundaries that are active usually lie between the two offset ridge segments. Although most transform fault boundaries usually lie in ocean basins, there are some that lie on the continental lithosphere. One example of this is the San Andreas Fault in California. The picture you are currently viewing is a diagram of transform fault boundaries. Hotspots are small volcanic regions that are usually a few hundred kilometers across. Hotspots form when hotter than normal mantle material, called a mantle plume, goes up toward the surface. Once the plume reaches the top of the mantle, magma forms. The result is a small volcanic region. Most hotspots have lasted for millions of years and are still active today. An example of hotspots are the volcanic mountains that make up the islands of Hawaii.